Hello all, I am Dr. Prabhas Sanjanmal. In today's class, we'll discuss about some problems that are related to Rice theorem for undecidability. We have already discussed about the theorem. What is the meaning of Rice theorem? We have already discussed in the previous class. Okay, so in this class, we'll mainly discuss about the problems that are related to Rice theorem. Okay, so first one, the first problem. The first problem, does the given RL means what? Recursive enumerable language. Okay, does the given RL language is regular language? So this problem is decidable or undecidable. First, we'll check, can we apply the Rice theorem or not on this problem? This is one of the problem. This is one of the problem. Okay, so first we'll see, can we apply the Rice theorem on this problem or not? This is the important point. Okay, so what is the meaning of Rice theorem? We have already discussed. Rice theorem means what? Any non-trivial property of RL language, means recursive enumerable language, is what? Undecidable. Okay, we have already discussed in the previous class. Please ask this video. Okay, so here sorry, so here we'll discuss about what does the given RL means a recursive enumerable language, regular language or not. First we'll see. First we'll draw the first we'll check the trivial and non-trivial property. Okay, so this is the what? Set of domain part. Domain part means what? Set of RL, set of RL languages, and this is the range part. Range part contains what? 0, 1. Range part contains 0 and 1. Set of RL languages. Set of RL languages, for examples like L1, L2, L3, L4, up to like infinity. Up to like infinity, because this is called as what? Set of all RL languages. Set of all RL languages like L1, L2, L3, L4, L infinity, like this. Okay. So question is here, what does the given RL means? RL means subset of some languages. For example, like, does the given RL is regular language or not? So just see, every regular is called as RL. Every regular is called as RL, but every RL need not be regular language. Okay, need not be regular language. Just say there are some of the languages. This is called as what? In the domain part. In the domain part, domain contains what? Set of RL languages, means L1, L2, L3, L4, L infinity. That means some of the languages may be regular, some of the languages may be regular, but some of the languages may not be regular. May not be regular. That means those are not regular, it will map with 0. Those are regular, it will map with 1. So say it will map with 1, means some of the languages. For example, like L2 is what? L2 map with 1. Here L2 map with 1. L2 map with 1 means what? It must be L2 language must be regular. See, L1 map with 0. That means L1 will present in what? In this area. Means L1, just say L1 is RL, but L1 need not be regular language. L2 is regular, but as well as recursive enumerable languages. So that's why does the given RL is regular language or not? So some of the languages may be regular. So that's why some of the languages means out of all sets. Out of all sets, some of languages may map with 1, but some of the languages may not, may map with 0. Okay, so this is called as which property? Non-trivial property of non-trivial. This is called as non-trivial property. This is called as non-trivial property of RL. So what is the meaning of non-trivial property of RL language? We have already discussed about in the previous class. Please watch this video. This is called as what? Non-trivial property of RL. Since it satisfies the non-trivial property of RL language, so this problem is what? Undecidable problem. So this problem is called as what? Undecidable problem. Now we'll see the next example. What does the given RL language, does the given RL empty or not? How to know that? Similarly, we will draw the domain and range set. Domain. Okay, similarly, we will draw the domain and range set. Okay, some of the, this is called as what? Set of RL. Domain always contains set of RL. So similarly, it contains the language like L1, L2 up to L infinity languages. So this is 0 and 1. So some of the languages play infinitive. Okay, some of the languages may connect with 1, means some of the languages may be empty. Out of these total languages, some of languages may be empty, but some of the languages may not empty. But these are the RL languages, so it will connect with 0. So this is called what? Non-trivial property. This is called as non-trivial property. This is called as non-trivial property of RL. Non-trivial property of, since it satisfies what? Non-trivial property of RL languages means, so this problem is what? Undecidable. This problem is what? Undecidable. Now we'll see the next problem. Does the given RL language complete? So similarly, we'll draw the domain set and range set. Domain set means what? Set of RL. Set of RL. So similarly, it contains many languages L1, L2 up to L infinity. So 0, 1. Some of languages may be complete. Some of the languages may be complete and some of the language may not complete. But both are RL. So does the given RL is complete? So some of languages may map with 1, and but some of the languages may not map with 1. So some of the language may be map with 1 and some of the languages may map with 0. Okay. So similarly, it is what? Non-trivial property. Non-trivial property of RL languages. Since it satisfies the non-trivial property of RL languages, so this problem is what? Undecidable. The fourth one, does the given RL contain string of length 10? Okay, similarly, now we'll draw the domain and range. Range contains 0, 1. Domain is what? Set of RL. Set of RL. Does the given RL contain what? String of length 10. String of length 10. That means it contains some languages L1, L2, L3, L infinity. Some of the languages. Say some of the languages may contain the string of length 10. Let it will map with 1. But some may not contain the string of length 10. That means it will map with what? 10. So this is called as what? Non-trivial property of RL language. This is called a non-trivial property of RL language. So this problem is what? Undecidable. Okay. Now we'll see the next one. Does the RL contains even length string? Does the RL contains what? Even length string. So now similarly we'll draw the domain and range. Domain contains what? Set of RL. It contains some language L1, L2, L3, like L infinity. Okay. Does the RL contains even length string? Yes. Some languages may contain even length string, and some languages may not contain even length string. Means it may contain some odd length string, but it will map with 0 if it contains, means some of the means RL language contains even length string, means it will map with 1. So it is what? Non-trivial property. Non-trivial property of RL languages. Non-trivial property of RL languages means it is undecidable. Okay. Now we'll see the next problem. Does the given RL contain string ending as 000? Ending as 000 means every string must end with what? 000. So domain, this is the range 0, 1. Domain contains what? Set of RL. Domain contains set of RL. Set of RL like L1, L2, L3 up to L infinity. Does the given RL contain string ending as 000? Yes, some string may contain the string that ends with 000, but some may not. Some may not. So this is called as what? Non-trivial property. Non-trivial property of RL language. RL. This is called as what? Non-trivial property of RL language. That means this problem is what? Undecidable. Okay. So similar types of questions I'll discuss in the next class also. Next class it is a little bit different from this problem. Okay, but we'll discuss many more problems in the means that are related to rice problem in the next class. Okay, thanks for watching.